I just wanted to welcome everyone to this industry talk. I've been spending this last couple of minutes talking to Jack, who's going to be our speaker. A little intro to me first. I'm Erica. I'm a junior. I'm in blockchain at Berkeley as the course admin for the education team, and I'm studying behavioral economics through the interdisciplinary studies field, and just recently joined the accelerator. And I'm really stoked to be here with Jack, and I'd love for him to show himself off and give us an intro too.
Sure. Hi, everyone. I'm Jack Kolb. I'm a PhD student here in EECS at Berkeley. This is my 6th year as a grad student, so almost done. And I've been involved in lots of different research projects, including a couple on blockchain that I'll tell you all more about later. And I think Erica mentioned I should talk about any fun things I like to do. So I thought I'd mention hiking, running, cross-country skiing, usually followed by eating a lot of food to recover from the activity after. So
Yeah, I think that recently during quarantine, a lot of people have picked up like baking and all those things. I'm not the best at that. I always have to use pre-made ingredients for my baking ventures, but
right. Yeah,
hopefully
my,
not the
my
same.
brother seems to have gotten all the baking talent in the family, so I don't even try.
Yeah, totally. Um, one thing that really jumps out when you say that is, have you been in grad school for like 6 years already?
Yes. So when you do a PhD, it tends to take a bit longer. And it also varies a little bit by like which subfield of computer science you're in. But yes, this is my 6th year. So I guess I've been in for 5 years and this is my 6th, but a long time either way.
Right. Um, what what are you working on? What did you start working on when you started grad school? And do you know if you could sort of, I know it's a long way down memory lane, but can you like, are there any pieces of work that really jump out at you as you reminisce?
Sure. Yeah. Well, it's kind of funny because there's like two ways things jump out at me. There's either like, oh, that was like a really good paper that we published that had really strong results, or more like that was a really fun collaboration where I got to learn a lot and like meet new people. So I guess most recently I'm working on security and verification for smart contracts. So I can talk more about that maybe in a few minutes. But I've also worked on Wave, which was a system that was originally built on a blockchain for authentication and authorization. And that originally tied into this kind of IoT embedded systems vision that was kind of cool. I've also done some fun collaborations. So I did one with some folks over in civil engineering where they were trying to process LiDAR data from rock masses and try to like speed up the computations. So that was more of like a parallel computing, high performance computing research project that was really fun. I've done some work on like machine learning and education. And then I've also done some work on computer vision as well. So lots of different topics I've touched on in my time.
Oh, yeah, that's definitely what I'm picking up here is lots of different topics, super interdisciplinary. Um, I mean, how do you even decide to take on one of these projects if it seems like there's so many options out there?
Right. Yeah, definitely. Well, what's nice about being an academic and being in grad school is you do get to pursue your own interests a lot. So you get to go out and try and read other papers or just learn about new things and kind of see what excites you or see where you find potential to maybe improve upon what other people have done or build on it. And a lot of it also depends on the colleagues you have around you. So if like, someone who you're friends with or who works in the same lab as you gets interested in something, a lot of times they'll kind of try to bring you along and have you help them out and collaborate. And so you get to learn a lot of new things that way. So one of my really good friends was pretty deep into computer vision, and that's how I got into that kind of topic for a research project as well.
Oh my goodness, that's awesome. I don't know if anyone else in the audience shares this, but I'm not actually super familiar with what computer vision is, so love to learn now.
Okay, well, wow, I wish my friend was here to explain, but basically, I'll explain it in terms of his project, which was the idea that like someday buildings are going to have electronic components, controllable components all over the place, like light switches or printers or projectors, and all that stuff is going to be at some point kind of controllable from computers. And so his idea was, well, you don't want to have to go and like look up the account to log into to control this or control that. What if I could just take my phone and take a picture of this thing and then like an interface to control it would pop up? And so you need computer vision techniques for a couple of different parts of that. One is once you take a photo, you have to localize where that is, say in a building or an environment. And then you have to know what you're looking at. So kind of like object recognition. And so his project was on taking on both those tasks and trying to get kind of this like seamless control scheme going where like the very futuristic vision was someday all I need is a smartphone and I could like interact with lights or cameras or projectors or other systems that are kind of built in around the environment.
Wow.
So very cool stuff. Yeah.
Where has that taken him? Have you kept tabs on the project?
Yeah, so the project was published in this kind of like journal on ubiquitous computing, which was really cool. And I think it got a lot of attention there. And then he actually now works for Waymo, the self-driving car company. So you can already imagine lots of computer vision applications there where like the car is driving, it has cameras and LiDAR systems. You want to perceive obstacles that you need to stop for or avoid, or signs and intersection markings to know how to navigate. So he's taken a lot of his expertise and background and now applies it every day in his job, which I think he really likes a lot.
Oh, right. Yeah, absolutely. Yeah, it seems like there's just so many opportunities available in terms of the circles that you've been working around in. And one of those circles is like blockchain at Berkeley. So sort of, do you want to talk about how you got the steps that occurred for you to be here with us so we could hear all these stories?
Sure. So yeah, okay. So well, I first got into blockchain kind of like I said through a colleague of mine, Michael Anderson, who is another graduate student in my group. And again, this is one of those times where like being in grad school is really fun because someone else can introduce you to something, you learn about it, and you kind of build on that. And so basically like we were like working really late, in the lab coding, I don't know, midnight or 1 a.m. or something. And he's like, oh, I have this idea for the system I'm trying to build. And I have like some really early code. Can you just kind of test it out for me and run through kind of the paces and see if it works and everything. So that eventually became Wave, which I know some of you may have heard of. So I was kind of like the first Wave user, I guess, ever. And so his vision was, so our lab originally was kind of founded more focused on embedded systems, low power computing, and like Internet of Things kind of vision. And so his idea was to build this kind of messaging infrastructure where like sensors could publish data or internet services could consume sensor data and try and process it and provide a service to customers or something. And so immediately you kind of realize that security is a big concern there. You only want people who are allowed to read some sensors data to actually have access to that data stream. Or you only want services that have been given permission to consume data to be allowed to go and read messages from those sensors and process them. So Wave actually started off as this kind of messaging IoT system. And originally in the first iteration, the idea was like if I'm a sensor owner or something, I could grant permission for other people to read the sensors, and we would just store that in some centralized database and keep the solution really simple. But then we kind of started thinking about, well, what if you have multiple buildings or you have kind of like this hierarchical structure where like especially in like commercial buildings, there's like a manager that runs the whole place, and they might give like subsets of permissions to specific labs or research groups that occupy different parts of the building. And so that motivated this kind of more decentralized model where we thought we'd store permissions on a blockchain. And there, we thought, oh, great, there's no central authority and it's tamper resistant. You can audit records of permissions that have been granted historically. So you can see exactly why, person X gets to go and read temperature data from some room in the building. And so that is how we got into blockchain. And that's how I kind of, got excited and learned about it and then took off from there.
Yeah. And I think if someone has access to these like Wave papers, it's sort of like, has it sort of changed form since the project started in any way?
Sorry, could you repeat that? I was just distracted for a second.
Oh, no problem. I was asking how Wave has sort of changed and how your understanding of blockchain has changed since
Right.
Wave
Yeah.
your introduction.
Right. So basically we ran Wave on like an Ethereum blockchain, wrote some contracts to mediate permissions and things like that. And it, it worked fairly well. And we did a lot of experiments to show that it was, decently scalable, and like the burden to participate in the system wasn't too high. And so that was all, pretty good. But we didn't like some of the issues with latency, and we kind of started to think more critically about what elements of blockchain we really needed and what ones we didn't. And so we knew we really liked the fact that everything was auditable. You could, see a history of modifications to permissions and system state. We liked that, you could protect against tampering or later modification. And so we started looking at some other similar things, particularly, so Google has done some work on a project called certificate transparency. I can get into more about what that means, but basically they were just looking for a storage system where you could audit everything, but you would permit some centralization as long as you could audit what those centralized parties were doing. So we kind of redesigned Wave, where we didn't use blockchain. We used a system built more on this idea from Google with Merkle trees and a few other cryptographic primitives. And so the short summary of that is we lost kind of like the full decentralization, and we lost smart contracts as an enforcement mechanism, but we got a much better performance. And the argument that Michael would always make is, well, okay, so someone could break the rules, but at least we can audit them and we can see exactly what they've done. So we could kind of catch them out, and you could say stop using that storage provider or that system participant in the future. So it was a really interesting exercise in trying to think critically about blockchain, what it's good at, what it's not good at, what are the costs of using one, and how can we still get a lot of the same benefits with a more simple system design.
Oh, yeah. Thank you so much for that rundown. It seems like definitely deserve a lot of credit for having the realization that a technology we're intending to use wouldn't necessarily be as necessary to implement after all. And
Right.
yeah, how did
And it
that?
wasn't, yeah, and it also just like, it wasn't like we were just like, oh, blockchain is bad, like we're done with it. It was kind of like, oh, it's great, but let's try to think about what our priorities are and where, the strengths of blockchain versus the weaknesses of blockchain kind of fit with our use case.
Yeah. Do you feel like that's sort of part of the like academic process, is always tweaking and figuring out that, oh, this seemed great, but we might need something wholly different?
Yeah, definitely. I think, especially like if you want to do research or be an academic, it's really valuable to kind of be able to take a step back and not get too personally invested in like one side or the other of like a debate, but try and just, kind of read different sources, think for yourself, be open to things changing when, new information or new system designs or ideas come to light. And so I think that was definitely like a case where having that academic mindset was a real benefit. Being able to say, okay, like we had this idea, we felt really strongly about it, but it turns out when we think more carefully about the problem, there's maybe other solutions that could be better.
Yeah.
And I think that's like a really common theme as well, just like being able to read and learn and kind of reserve judgment until you have all the facts, and still letting your mind be changed if new ideas come up.
Yeah. Um, Thank you for that. I'm going to read a question from Joe from the audience, and he's saying, why hasn't there been an Ethereum or BitShare system with Monero or Dash like privacy for keeping ERC20 like assets private? This is essential.
Yeah, so I can't speak too much to ERC20 assets because we didn't work with those too much in Wave, but I know there's a lot of ongoing work with like zero knowledge proofs and Monero with like ring signatures and stuff. And I think Ethereum 2.0 is going to have some new features that are trying to address some of these problems. So I think they're working on it. But I can say a little bit about with Wave. I think maybe this question maybe came up because Wave was really big on privacy in some respects. So if you imagine this kind of permission system I talked about before, you could kind of think of it as a directed graph in the computer science sense, where the nodes in the graph are entities or like people, and the edges are grants of permissions. And so originally we put the whole graph basically onto the whole graph structure on the blockchain. And so that's kind of nice because it's auditable, it's open, it's transparent. But then like it's transparent in kind of a negative sense as well, where now anybody can read the graph and they can infer a lot of things based on what permissions have been granted. So, for example, if they see that Jack is allowed to consume sensor data from 410 Soda Hall, then that's probably where Jack has his office in Soda Hall. And so another part of the transformation of Wave was trying to make this graph more private. So you only see permissions that are relevant to you. And there was a lot of work that Michael Anderson and Sam Kumar, another graduate student, did using a lot of very interesting cryptographic tools to achieve that kind of vision, where you could store the graph on a blockchain or on kind of a centralized storage service that had the crypto I talked about earlier. But when I go to look at it, I can only decrypt and see permissions that are relevant to me specifically.
Thank you for that.
Sure.
To segue into another question, which highlights an important aspect of interests about Wave, I
Right.
asking, how do you handle the privacy / efficiency trade-off in academia? Wave was taken off a blockchain, and want to hear about more like why.
Yeah. Okay. So I'll start with the general answer and then I can get a little more specific. So in academia, a lot of times systems that were really that are first proposed that are great for privacy are not so great for performance. And then future work tries to go and look at how you can make things more and more performant. So usually like in academia, it depends what your value, you claim to be adding value to the state of the art, what your claims are. And it's okay sometimes if you say, we found this new design, this new system that's very private, but it's not very efficient. And then future work might come and say, hey, this existing privacy system, we've made it 200% more efficient or whatever. And that can be another great result that happens in the academic space. With Wave, what happened was we felt like we had demonstrated scalability up to like a building or like small city level. So we did like these little simulations. And this is a big part of doing computer science research, especially in like systems and networking, where you try to build benchmarks, run experiments to see how fast your system really is. But when we kind of pushed the envelope further and tried to simulate more participants in the system, a higher rate of traffic, of permissions being granted and revoked and verified against what's stored on the blockchain, it didn't perform as well in some of those later experiments. And again, I think we also just kind of unrelated kind of learned about this Google certificate of transparency and log derived map kind of structures. And it took us a little bit to kind of put together, wait a minute, we can take this new idea, apply it to our problem, and probably get better performance. So I guess for Wave, it was a combination of some experimental results and then getting inspired by another idea that we saw to try and shift away from blockchain.
Okay, thank you. That was really informative and almost raises the question for me of if you've ever run into that process before, or if what happened with Wave, where a different direction was taken, that was like a wholly new experience.
Yeah, that's a really good example. With the computer vision stuff, unfortunately I can't speak with like as much technical depth because it's not my core area, but I know that we went through like a few different approaches to try and like solve this localization problem, which is like, how do I know where exactly I'm in a building based on a photo I've taken? And there were trade-offs there between how much like setup work you have to do to make this kind of system viable versus like how accurate the localization is going to be. And so we kind of went through a few iterations, and so we kind of settled on this solution where if you say we're going to provision this really fancy smartphone control system in your building, you'd have to go and create like basically like a three-dimensional model of the entire building. So someone has to go through and record with like a special depth camera all the different places that someone could be where they take photos from. And then you take this video footage, you construct a point cloud, and then you build your model from that. And so we kind of were reluctant to do this because we were thinking, oh, well, this is like asking a lot of someone who wants to set up this system. But it's like so much more accurate for the users of the system once that like one-time initialization has been performed. So I guess that was a case where we took a new approach, and like we were initially a little hesitant about it, but we thought that the results for like the user experience justified the expense of the setup process.
Okay. Awesome. Glad to hear that this intellectual like development is like occurring in like multiple examples for you.
Right.
There's
Yeah, that's pretty normal for academia.
Yeah, absolutely. There's a question in the chat for in the IoT and sensor data space, does proof of stake look promising or the proof of work?
Yeah, that's a good question. So in IoT, yeah, okay. So I think there are like two issues, which are like if you have IoT devices, do they participate in the blockchain at all? And if so, like what form does that take? That might be part of what's motivating your question. And if not, feel free to follow up in the chat. So in Wave, what we actually did is we wanted two main decisions. One was that sensor data itself does not interact with the blockchain. That's a separate messaging system. It's the ability to demonstrate permission to subscribe to this data that runs through the blockchain. So control goes through blockchain, but data does not, was one big thing we wanted to do. And the other thing we did was we chose kind of a system design where IoT devices wouldn't participate directly in any of the control decisions either. They'd have like a proxy or an agent that would do a lot of the heavy lifting of the crypto and computations, and that would be participating in the blockchain. You can imagine just having like a simple symmetrically encrypted channel between the sensor and its proxy that you would set up at the beginning. And so that way, computation is kept kind of cheap on the sensor, hard stuff is done at the proxy, and then you don't have to worry too much about proof of stake or proof of work from the sensor point of view. So we kind of kept the consensus and blockchain mechanisms independent of the IoT devices and sensors themselves in Wave, at least.
Okay. I think that we've been talking about academic research for a little bit, and I can't help but ask, I knew that you were a part of the blockchain working group, and I've contributed to some research for them on digital identity for homeless populations in California. But
Cool.
onto you, I'd love to hear about like what ventures you were involved in when you were there.
Yeah, so right, so Blockchain Working Group is kind of this cross-department group at Berkeley that coordinates research and has a meeting where people get together every month. And so they've helped kind of support some of the smart contract work I've been doing. So that's become its own little kind of pocket of research that people are really interested in. I'm sure a lot of you are already familiar with the fact that normally you deploy a contract to the blockchain and its code is immutable. So if there's like a bug or a problem, you can't usually fix it after the fact. And the blockchain vision is very reliant on this kind of hope that contracts are going to be this effective way to enforce terms of agreements between parties that don't trust each other, but trust that contract and its code to adhere to some agreed upon set of rules. So you can kind of naturally imagine that you'd want to have effective tools to test and instrument contracts, be sure that they're correct before you go and deploy them onto the blockchain. So I've been working on some research that's been kind of funded and supported by the working group to build new tools to kind of author and then validate contracts before deployment. And so that's been one big part of my experience with them. And the other fun part has just been kind of learning and talking from a lot of different people. So for me personally, although I'm kind of in the CS department, I really like to see how CS ideas kind of intersect and support other fields. So I mentioned like working with civil engineering as being really fun. And then I like how the working group, you can talk to people from finance or from public policy or different engineering and science disciplines and kind of see how they want to use blockchain or computer science ideas in their own work.
Yeah. Before things went virtual, do you have any particular like best memories or like particular examples of when you really felt like you benefited from the blockchain working group due to being surrounded by different types of people?
Yeah, well, it was really interesting. So there was what was it? I think so through the Citrus Institute, there was like a discussion on blockchain and voting and elections and why that may or may not be a good idea. And obviously right now we're all thinking about this, although this occurred a couple of years ago. And so it was really fun because through the working group, we kind of organized. And then I got to attend this event where a lot of like the leading experts on election security and like statistics and cryptography came in to give a presentation. So that was just like really thought provoking and really inspiring, just thinking about the fact that, the things we do as computer scientists really do matter. And also, thinking critically about sometimes, one of the main arguments from this presentation was sometimes throwing more computer science at a problem isn't necessarily the best solution. So, also being kind of humble about being a computer scientist that doesn't get to solve everything. It's a really cool field, but it fits into a bigger picture. And sometimes we are more of a supportive role, and sometimes maybe other solutions are more appropriate. So really fun to learn about that and see it.
Totally. Yeah. I mean, there's been dialogue recently about like blockchain mobile voting with even the USPS submitting a patent, but it's so important to be surrounded in these circles and eliminate noise and sometimes question, I don't know if that really requires extra technology thrown at it. Uh,
Right.
I think that's what a lot of Citrus and the blockchain working group are up to. It's like these public policy hubs that aim to just educate the public so they're not misunderstood about technology.
Right, exactly. And again, this isn't saying like, oh, computer science or blockchain is bad. It's just let's be critical about when we apply it, when we use it, and really, ensure we're using the best tools for the job at the time.
Mm-hmm. Yeah. Are there any particular like particular recent like world events where it's sort of related to blockchain that you've been keeping up with? I understand it's hard to read the news often. It can be upsetting and also.
Yeah, yeah. Um, hmm. I guess I can't think of like any big world events. I think you bring up a good point, which is like when you read proposals from companies that want to use blockchain and trying to decipher for yourself how much value or technical depth is really there. So you mentioned like USPS, or there have been a few other cases where companies have said, "Oh, let's just put things on blockchain," and you have to, kind of evaluate that for yourself. So I think that's again another kind of fun part about being an academic is you get to be a little more critical and thoughtful about like kind of digesting these announcements and trying to relate them back to the published work or previous solutions, and how likely they're really to work or not work.
Yeah.
So the one actually interesting experience I had was I did a project with Intel where they wanted to look at if they could run aspects of their supply chain infrastructure on blockchain. So the idea was like, Intel, for example, when they build a new foundry or like a new chip manufacturing facility, they buy really, really expensive equipment from a lot of different suppliers. And there's like these really complicated contracts that they have to write with like very involved warranty terms and contingencies. And so they basically were interested in, can we run like a blockchain and use smart contracts to enforce some of these contingencies? Because otherwise, what usually ends up happening is the Intel people go and look up in their database, when they think they purchased this piece of equipment that's now broken, and when they think the warranty expired, the supplier does the same thing. And a lot of times their two databases don't even match each other. And so the idea was, oh, well, blockchain could be this kind of source of ground truth, and it's auditable, it's tamper proof, and we'll just kind of collaborate and participate together in this blockchain. So it's really fun, both kind of being able to kind of share and educate them about blockchain, because a lot of them were computer scientists but not specialists in blockchain, or more like industrial engineers, and then to also get motivated and think about what their problems were and how blockchain might be able to solve their problems.
Mm-hmm. Yeah. Thank you for bringing up that example. That just makes me wonder, do you remember any of the specific ways that you would sort of educate people and in like what are
Right.
what were your most effective ways of drilling in the knowledge?
Yeah, that's a good question. It was something that was definitely very difficult, but very fun to try to do. Obviously, I think most people start with this metaphor of, there's like a ledger and you get to record entries, and smart contracts kind of get to like determine what entries go in the ledger and how you can modify parts of the ledger. So that analogy, which I think most people use, ended up kind of working okay. I think, one part that was really, really hard to explain was the like the transparency side of things, that if you put something on a blockchain, then unless you take some measures like encryption, anybody can go and read it who's participating on the network. And especially like when they started talking about, oh, could we get like lots of different suppliers to participate on the same blockchain with Intel, it's kind of like, well, you can, but I'm assuming there's like business sensitive information like pricing agreements or discounts that you don't want to reveal beyond the two parties that are in the contract that you're talking about. And so you have to kind of get into the separate area of privacy and anonymity. And so kind of conveying that and motivating those challenges was a little bit harder, I think, in the overall education effort.
I can totally see that, because you want to give a crash course on how blockchain works and the history of Bitcoin, but
Right.
you're just trying to figure out how to pinpoint this exact topic to make business run smoother and for people to understand use cases.
Right. And a lot of them, would have some familiarity with like SQL and relational databases. And so trying to convey how blockchain is different would sometimes also be an interesting endeavor.
Okay. Did you ever point resources to them, or were there any
Yes.
videos out before blockchain at Berkeley was a thing? Or
Yeah, so I think this was before blockchain at Berkeley was as big as it is now, for sure. And we actually, it was hard because there was kind of like, there's the Ethereum white paper, there's the Bitcoin, the 2008 paper from Satoshi Nakamoto, and then there's like a ton of blog posts and web pages. It was hard to find something authoritative to point them to. And so in those early days, it was like, sending them kind of these lists of lots of resources, or even like trying to build some slides to distill all these things into some digestible form. Because again, like a lot of them were kind of engineers, but weren't computer scientists. So they were kind of like, numerically and mathematically inclined, but didn't really understand some aspects of coding or cryptography. So in those days, I think resources were a little bit scarce, but I know that obviously BAB has a lot of cool things. And I know that a couple of universities have even written like textbooks at this point on blockchain that you can point people to. So today, I think it'd be different than it was when we started the project.
certainly. And there's just so many, like, for example, you said videos and blog posts. There's so many Medium articles out there where it's like a
Right.
comprehensive list with pages and sub pages of things to check out. And I
Yeah.
just exploded. It's almost too much information. So I think it could be really helpful if, from your analytical academic perspective, how do we cut through the ineffective white papers or the ineffective explanations?
Yeah, that's it. Okay, that's a good question. So I guess like if you're already like kind of technically inclined, then I always like to start at the source, which would be like the white papers from like Ethereum, the Ethereum yellow paper, the original Bitcoin paper. And then like usually when you're in academia, you do this kind of classic technique where you have these kind of few kind of starter resources, and then you try to look at, okay, what other resources cite or reference these? And then you kind of go and you look at those and you kind of work your way outward, kind of, like a breadth first search in a graph kind of thing. So that works also. I do that all the time, like reading like research papers in computer science as well, if I'm just trying to like get up to speed on a new topic or something. And then I think the thing is, at least when I was like trying to teach myself about blockchain, it just took time, and it took looking at lots of different resources and seeing, like where they agreed versus where someone would say something that didn't quite fit with other resources, and being a little more suspicious about that. So I think, just at that point, it was just kind of quantity and then surveying and trying to pick out the common themes that I could see.
This is new to me. The work outward,
Right.
that's definitely going to be effective. And I fully agree with, like, starting with the source. Do you remember
Right.
what happened when you read those papers? Like, what were your insights?
Yeah. Well, I remember, so when we started Wave and then we were going to move to blockchain, like I just took a weekend and just like dove into a ton of blockchain stuff to try and teach myself. And I remember like at least for me, it didn't really click for a while at first. Like I had to read a few things, and especially like, proof of work and mining is like such a cool idea, but so different than like most previous computer systems, that like that took a little bit of like a kind of a little aha moment, I guess. But I think once I kind of read and then was able to digest for a bit, I just think like things started to make more sense. And especially so one thing that's like a really powerful skill is if you can take something new and relate it back to things that have come before. So in like, especially like in distributed systems and networking, which are kind of my main research areas, like the same themes pop up again and again and again. And so you see kind of old ideas take on new form. And so with blockchain, like it was really fun to trace back and look at like the old kind of consensus ideas, like Paxos and then Byzantine fault tolerance and Raft and other kind of newer systems. And then there was actually a paper, I think it was like 2005, where it was called BAR fault tolerance for Byzantine altruistic rational, where you could already see like some of the seeds of Bitcoin in that paper. I would be very surprised if Satoshi Nakamoto didn't read that paper before writing the Bitcoin paper, where they talk about trying to take a more economic approach to modeling the behavior of participants in a distributed system. What are they incentivized to do versus what does the protocol say they're supposed to do? How can we make those things line up? And that paper kind of was looking at like distributed storage, and it assumed that you'd have like some way to prevent Sybil attacks or to assign like an identity to each participant. And they just kind of took that for granted. And then obviously you could argue that Bitcoin took that system and then proof of work kind of eliminated that assumption with the whole proof of work model, where now Sybil attacks aren't a factor and it's open to anybody to join and participate in. So I actually, unfortunately, didn't find this paper till after Bitcoin, but once I read that, it was kind of like this big moment to see like the sort of the heritage of Bitcoin and blockchain from like a systems perspective, which was really cool.
That sounds totally fascinating, especially BAR with an economic twist. Do you think, for my sake, being totally selfish here, but do you think you could elaborate on it a bit more?
Yeah. So, okay. So if you wanted to like roughly categorize like consensus, going all the way back to like old school computer science before blockchain. So obviously your goal is that everybody in the system kind of like makes the same decision together and they stay in sync on what the current state of the system is at any time. Then of course, one problem is, well, you have so many computers that odds are one of them is going to break or fail or stop communicating with the other members of the network at some point. And so that's, kind of crash fault tolerance. And so that's what Paxos, if you've heard of that, is a system to kind of solve that problem. And then Raft was like a more recent and hopefully kind of more understandable version of that. And then the next step up is called Byzantine fault tolerance. So that's where now it's not just that a computer could break, but it could sort of be evil in the sense that it might send incorrect messages to other participants, or it might lie and say that it agreed to do something and really it doesn't do that thing. So it might get out of sync with the rest of the network or confuse other kind of nodes in the system. And so they had to develop algorithms to try and address those kinds of problems. And it wasn't actually, so if you've ever heard kind of the big solution in the space is PBFT, or practical Byzantine fault tolerance. So a lot of ledger systems actually use this algorithm to achieve consensus. And that wasn't until like, I think 2000. So it's actually kind of recent in computer systems terms. And so then BAR was kind of the next step up, where they said, well, okay, so nodes can be Byzantine in the sense that they might lie or they might send incorrect messages. But other nodes might really just be in it for themselves. And if it doesn't benefit them to participate in the system's protocol or to keep up with the rest of the nodes and to follow along, they might try and deviate and just do something in their own self-interest. So bar fault tolerance was about tolerating both Byzantine and kind of rational self-motivated nodes in the same system. And as I mentioned, kind of one of the big assumptions they made was, well, we can design these protocols and use cryptography to kind of keep progress going and to maintain correctness in the system. But it relies on the fact that we can identify and we know every individual who's running and participating in the system. So it's still kind of a closed system, or it's still kind of like a permissioned blockchain in some sense. And then Bitcoin obviously kind of then was able to relax that assumption with proof of work and make it a public system with all the same guarantees. And you now don't have to have like a pre-arranged list of participants that are authenticated, and if they misbehave, you can attribute it to a specific party, kind of thing.
Wow. Yeah.
Hopefully that made sense. It probably got a little
No,
long, but
I'm just processing. That's all. It's all so incredibly interesting, and I'm definitely gonna check that out myself. I wonder if
yeah, if you want, I can send some links to like the papers I mentioned if anyone's interested in reading them.
I think it would be that would be great. And I'm sorry.
It's okay.
I think someone passed by. But yeah, I would really appreciate if you sent the links, and then I guess we can, I mean, you're sending external research, but I think we all really want to hear exactly what you're researching, because can't give enough attention to BAR and Satoshi.
Right. So as I mentioned, it's in kind of smart contract correctness and validation. So kind of like we were mostly motivated by Solidity. Hopefully some of you have experience writing code in that language and know that it can be a bit kind of tricky, because at least kind of my take is they try to make Solidity feel familiar and comfortable for programmers coming from other languages, but it doesn't sometimes accurately kind of convey or capture some of the subtleties to how things really execute on the blockchain, which is very different from how normal software and transactions execute. So there's kind of two pieces to the work. There's trying to develop a more simplified language for expressing and designing contracts that's kind of supposed to be less error prone, more user friendly, although it can be kind of hard to quantify those things. And the second piece is then taking what you've written and being able to test it and validate it so that you can be sure it's secure or it does what you expect it to do before you deploy it onto a blockchain for anybody to use, potentially malicious, who could go and try and break it or exploit it. So the validation technique we're using is called model checking, which it has been used a lot in systems, particularly for like parallel and concurrent software with like threading and concurrency. And so the idea is that if you're able to write down like some properties you want your contract to adhere to, so you could say, nobody's able to make an unbounded withdrawal of Ether from the contract like they could with the DAO and the whole reentrancy attack that happened there. Then the idea is that with model checking, you can go and you can explore like all the possible scenarios that this contract could ever find itself in. And you can check that its code will still enforce like the invariants or the properties that you want it to adhere to in production. So that's like a really high level summary, but kind of simplified programming language and then model checking for validation are the two big pieces.
Do you think that there's been that what you're studying has sort of become a lot more people have started to take notice and done their own research projects on it, or has it maintained relatively stagnant?
Yeah, the fun thing is there's a lot of different approaches to solving this problem. Like smart contract correctness is obviously like a pretty widespread goal and aspiration for people involved in blockchain. And so there are lots of different approaches you could try to take to solve the problem. And I think there's more people kind of getting involved in this space now and taking notice of the different techniques. So it's been fun to kind of talk to other researchers who are taking different approaches and kind of see what the strengths and weaknesses are of other possible solutions. There's a few startups that are trying to do kind of contract correctness as a kind of service and a subscription for contract developers. So I think it's definitely growing and getting more popular.
Mm-hmm. Do you have any examples of sort of what contract correctness might look like in different forms?
Yeah, sure. So so like the DAO is like a really famous vulnerability where basically there was an opportunity for somebody to withdraw a lot more virtual currency than they had legitimate claim to. And that was basically like a reentrancy bug, which if you're familiar with like multi-threaded or concurrent programming, that's like a classic problem from computer systems. So correctness would be ensuring that nobody can, like if they've deposited funds like in escrow or temporarily with a contract, they can only claim back the funds that they're legitimately entitled to. That'd be one aspect of correctness. Other times, like say you're like running like a simple game, like a betting game or something on the blockchain, then you'd assume that eventually like the game reaches some conclusive state, like, you know, you declare a winner, or there's some kind of tie, whatever. But that's kind of, in systems, it's called like a liveness constraint, like that you're able to make progress and reach some final result in your contract. So that's another aspect of correctness, like showing that you can eventually, you know, finish whatever task the contract was given. Like it can't be blocked or interrupted by a malicious user.
Cool, 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 cool. Do you think that's sort of at the forefront of like the academic sphere in terms of blockchain research, or would you say there's other things especially being highlighted right now?
Yeah, there's a lot going on for sure. That's one kind of subfield. And then there's, you know, trying to develop new consensus algorithms. So like I know Algorand, that I think many of you are familiar with like Silvio Macaulay, who is a professor at MIT. They were looking at more efficient consensus mechanisms using kind of newer cryptographic primitives. So that's another area. There's kind of the more classical like distributed computing and networking, how you can let blockchain scale larger. And then I guess there's also starting to be kind of studies in like game theory and economic modeling. Like how could you show that, kind of like that back to the bar fault tolerance idea, that everybody is incentivized to, you know, follow the proper protocol. So mining, I guess, like they've already definitely applied it to mining as one example, but trying to like generalize that to arbitrary smart contracts or protocols you want to enforce with a blockchain.
That reminds me of how last Thursday there was actually a lecture on like game theory and crypto economic incentives and mining
Right.
goals and selfish mining defenses. So do any of these topics you just listed, like, do you ever sort of just read about them on your own time? And again,
Yeah. So it was really cool because so there's this part of computer science called multi-agent systems, which I think was popular like 10 or 15 years ago, but I kind of learned about it because it's fun to see it come back with blockchain, where the idea was, like if you're familiar with game theory, there's this idea of like mechanism design, which is like, how do you design a game that actually incentivizes or makes everybody's, you know, most logical strategy be to tell the truth and follow the rules. And you can imagine like a smart contract is basically an exercise in mechanism design. So I've been really interested in, are there going to be like some ideas or conclusions from multi-agent systems that are going to come into play with contracts and blockchain? This was originally applied to like distributed systems and distributed optimization. And this was all, you know, created before blockchains really brought kind of economics and incentives back into the fore. So I think it'll be cool to see how that stuff comes back again with new research in blockchain.
absolutely. I think it's so fascinating to see how game theory and like things like Nash equilibrium or the prisoner's dilemma
Right,
can factor into how people can behave amicably within the blockchain space. So
right,
that's just another example of how interdisciplinary this sphere is and how we're always trying to figure out like new innovations. But it's really
right.
great when these different disciplines interact.
Yeah, and that's been a really fun part of doing blockchain research, is just kind of seeing, like I said when I was talking about the working group, just like seeing all the different pieces and fields that are interested or at play in the space.
Mm-hmm. Yeah, I feel. Have you ever come across like a blockchain topic where you felt that you didn't have like the interdisciplinary knowledge for it to like fully grasp it?
I think yeah, sometimes like with some of like the public policy or like engineering or science topics, it's been harder just because I have less background. So there was a really interesting paper actually from an engineer at Berkeley that was on trying to run like decentralized energy grids on blockchain. And the vision was that like as more and more people like, you know, are generating power from solar panels and like having batteries for on-site storage, and they want to sell electricity back to the grid rather than just consuming it. Um, like how do we make this more decentralized? And so it was really interesting reading about it, but I also feel like I didn't understand a lot of like the weird energy grid engineering aspects of it either, because it was using like really sophisticated optimization methods, and they were somehow like specifically designed for the energy grid as like as a marketplace. And I definitely couldn't like appreciate the subtleties there, even though I thought it was really fun.
There was a couple lectures ago, like a little section on sort of like carbon credits and microgrids and all these
Yeah,
different.
microgrids. That's the term I couldn't, yes, that's the term I couldn't think of. Right.
There's just so many initiatives out there, and people are trying to figure out how to like democratically harvest their own energy together. And um, very interesting to read about, and very interesting to see that there's a lot of like blockchain and energy conferences where these conversations take place.
Right. Yeah, definitely.
Definitely that's the place to be if you that's definitely the place for people to go if they want to find out more about like blockchain's intersection with energy, because I feel like, yeah, you have to have so many you've had to be in so many rooms to really understand those kind of initiatives.
Yeah, definitely. And also, just like even like fully motivating the problem, like the energy grid, it turns out it's like this amazing kind of distributed system, even, outside of computer science. So like just appreciating that is fun, but like kind of hard to do without the background.
Yeah. Do you ever feel like sorry, let me sorry.
No
Do you
worries.
do you ever come across topics in the industry where you read about it, but and then you're excited, but then you do some more research and you realize that there isn't enough on it, and you're like, oh, I wish I knew.
Oh, hmm. Um, I guess I can't think of one off the top of my head. I think I've definitely had times where I see like this really cool industry announcement and like um, you can tell that it's like kind of like behind the leading academic efforts, but that's not necessarily a bad thing because like I was talking about before, sometimes like academia produces these ideas or systems that are still really like kind of ill-formed or like not performant. And so it takes some time, I think, for industry to catch up and or maybe even improve them to the point where they can really be put in front of real users and customers.
Mhm.
So sometimes I'm kind of like, oh, okay, like that's probably applying these ideas and they could maybe go further and do these other things, but maybe they're too new for industry to kind of deploy at scale yet.
Okay. I think for me, it's sometimes I see these like flashy announcements and then I go to the website and there isn't enough information. And so I'm wishing that
Right.
sometimes there was like more dissemination of what's going on behind the scenes. So maybe you haven't seen too many like understudied topics, but maybe have you ever like gotten ad nauseum from some sort of like research topic that far too many blockchain researchers are into, and we've sort of already closed the
Hmm.
chapter on it?
I can't think of anything, I guess not yet. I think, um, hmm. No, because I think blockchain is still new enough that we're still trying to figure out even like what the long-term vision for this technology is going to be. I think there's still like a lot of research and debate and discussion to occur in the academic sphere. So I can't think of like one area where it's like, oh, that's been studied to death, like we're so done with it. Um, Also, like the fun thing is like as soon as like you start thinking that, like someone will come along with a paper or an idea that like totally changes your conception, which is always really fun. And so staying open to that possibilities is always, I think, nice if you can do it.
Mhm.
I will say that I've gotten really tired of like all the ICO announcements, but that's probably true for everybody in blockchain.
Yeah. Should be done, but thought I put it out there. But yeah, definitely so much more to be done. And when you talk about ICOs, I sort of wonder if you've ever um, looked into how like cryptocurrency operates in different countries. Like, do you know anything about that?
No, I have a colleague who has done like a fair amount of research into that. I haven't personally. I have followed like some of the things in the US with like the SEC trying to decide if like an ICO was a security or not and stuff like that. But outside the US, I haven't followed it as much. I know that there's lots of systems that are like have the vision of bringing like financial services to countries that don't traditionally have this kind of infrastructure. So, or even just like reliable record keeping. So a really good friend of mine is from Egypt, and he's explaining to me that over there, like even property records are not, this government maintained property records are not reliable, where they'll lose things or they'll throw things out, or there's corruption where someone will kind of acquire the deed to a property illegally. And so, maybe blockchain someday can help bring things beyond financial services to these other countries, but I think it'll take some time yet.
Yeah. There's a question from Ayush asking about thoughts on the different labs at Berkeley and EECS. I know that you worked with the RISE lab.
Right. Oh, yeah. Okay. So, yes, I work with the RISE lab, which it's pretty broad, but it's definitely a great lab. There's a lot of machine learning going on. There is, in particular, there's both like theory and applications there. There's people working on trying to do like secure federated learning, where like different companies would share data sets to build models without like revealing what's in those data sets. There's work on self-driving vehicles. So RISE is kind of very broad, but mostly machine learning. There's the Aspire lab, or maybe the Adept lab, I think they're called now. And they're more like computer architecture and hardware. So if you've taken 61C, RISC-V came out of that lab actually. And then there's Bear, which is like Berkeley AI Research, which does, I think, a little bit more kind of theory machine learning. So there's a lot of different labs that are out there, and they all kind of have their little focus areas with some overlap, but they're all doing pretty amazing work. There's also like a networking lab, so NetSys, if you're more into like computer communications and protocols. And then for getting involved in research, okay, so the place to start is figure out kind of like what you're interested in or what excites you. Like that's the first step, I'd say. And then try to find a lab or like a professor that's working on something related to that. And then I would say like do some scouting and some legwork, like look at their website, try to read recent papers they've written to get a sense of what they're working on or like where their priorities might lie. And then you kind of just have to, you could try like contacting them. And so you could try contacting a professor, but faculty at Berkeley are very busy, so they may not answer you. Another thing you could try to do is find out who their grad students are that are working in the lab and are studying these things, and try contacting them. They tend to be more responsive because they have less things on their plate usually. And so just like trying to introduce yourself and ask if you could chat with them about what they're working on and see if they have any undergrads they're looking to take on is one way to go about it. There are also like programs. So there's URAP, and I think there's at least one more where you can try to get like actually some funding for a research project and find a mentor. So a lot of grad students or professors will look at those programs and see who signed up for them to find potential research recruits. So that's another good thing to do. And at least before COVID hit, the IEEE student group would have like a little networking event where graduate students and undergrads would both show up and they would talk to each other, and you would try and find research collaborations you could do through that. So that's another avenue you could try to pursue if you're looking for research opportunities.
Yeah, thank you. Do you have any advice besides that that's come from like your own experience back in undergrad? Maybe you did research.
Sure.
And then, yeah.
Yeah, well, so when I was an undergrad, I took the first approach. Like I tried to find some interesting work, and I just emailed and tried to see who would respond. And it helps a lot if you can try email, but I guess these days like offer to Zoom or to meet in like kind of synchronously, because then like it's kind of nerve-wracking, but if like you're up for it, then it kind of puts them on the spot more. Like you can ask more questions, you can be more direct, and you can usually get I'd say like it's easier to get like a positive answer when like you've had a chance to chat with someone directly than just indirectly via email. So that's what I did. Like I emailed, I met with a professor and grad student, and then like just kind of got started. So that's what I did. And then I kind of like switched labs when I was an undergrad. And again, like I just tried to I emailed, and then the other secret is just like show up to someone's office hours as well, and just try and kind of track them down there, because there's like they have to be there, and if they're not answering your emails, they have to try and talk to you in like their Zoom office hours, or hopefully someday in-person office hours. So that's another good technique you can do too. And that's what I did in undergrad.
Okay. So be persistent, do your research, and try to be personable. So
Yes, and don't take it personally, like if they don't answer you, or if they answer you once and then don't get back to you. I once saw my PhD advisor had 32,000 unread emails in his inbox. So they get just overwhelmed with stuff. And if they don't answer you, it's probably because they're really busy, not because it's like they're not interested or it's a personal thing. So you just kind of have to keep going and be persistent, like you said.
okay. Well, good to know for everyone listening.
Yep.
Be confident, stand up straight, bother them in their Zoom meetings, please. But be
Don't tell them I told you that, but
also
it does work.
consider. Yeah. There's another question. How often do you see distributed ledger technology research in an academic institution be applied to industry? And can you point to any examples?
Yeah, I guess the space I know best is smart contracts validation. So there's been a couple efforts that have basically resulted in startups. And so one is like Securify, which is from a university in Switzerland. So they went and they made a product out of that, and it's now I think a subscription service or something. So that's like one good example where DLT research really did translate to actual work. And then there was another similar effort. So there was a smart contract language called Scilla, Scilla, that was also kind of like my work, trying to attack the complexity of Solidity and have something more verifiable that you write your contracts in. And that I think became part of the Zilliqa, Zilliqa chain. So they took their whole programming language and like baked it right into this commercial ledger system. And actually what was kind of cool was when they wrote their paper and tried to explain, what they had done, their like experimental evaluation could be real users on the Zilliqa ecosystem using their language to build contracts. So that was kind of a cool case where industry and academia kind of helped each other in some way.
Thank you. Yeah, that's a great question, and very helpful. Do you ever see like ventures where you almost wish there was like a blockchain application to it? Because sometimes you have to be very selective with what actually requires a blockchain. But have you ever actually wanted one?
Right. So you're kind of talking about the flip side, right? It's where they don't have a blockchain, and like you have this insight. Oh, actually, if they use the blockchain, that would be, hmm. I guess I can't think of one like immediately, but I guess like so the certificate transparency thing I mentioned before from Google. So this will be like a really 10,000 foot explanation, but like when you connect to a website, they try to authenticate or prove that they are really who you think they are by presenting a certificate to your browser. And so like, you like talk to your bank, they have a certificate that says they're really Wells Fargo or Bank of America or whatever. So you're not talking to some impersonating server. And it turns out that you trust that the certificate is legitimate because it was given to them by a certificate authority like Google or Symantec or VeriSign. And so the whole certificate transparency effort was to try and prevent misbehavior by these certificate authorities from either like accidentally deleting a certificate or issuing an incorrect certificate to somebody that says they're your bank when they're not really your bank. And so it's kind of nice because you can audit them, but you can't prevent them from committing these kind of misdeeds in the first place. So although they would probably never agree to it because, well, for a variety of reasons, if you were somehow able to apply blockchain to this problem, you could actually prevent these kind of fraudulent or invalid certificates from being issued much more effectively. It wouldn't be like 100%, but it'd be better than being able to say, it wouldn't be just that you can say they did something wrong. It's that they'd have to circumvent the blockchain to do something wrong, which is hopefully much harder. So I guess that's one example, but I probably honestly don't see that materializing anytime soon.
Okay. Right. Have you, I feel like, have you noticed a couple extra like institutions starting to incorporate blockchain technology into their research after like hesitation? Like for example, Jamie Dimon from JP Morgan,
Right.
all these new, like recent headlines with different companies saying they're willing to try things out. How does the academic sphere like feel about that?
I mean, we're always happy when something that we think is cool and needs more attention or more research attention gets excitement from industry, because usually then industry tends to fund projects to do the research that we all want to accomplish in academia. So I think we definitely view that positively. I think sometimes there is some concern that, like, if a company or like an entity gets too enthusiastic and tries to overplay their hand with blockchain, it kind of makes the whole technology look less attractive to other industries or other consumers. So I guess that's like one kind of flip side, but mostly I think we're happy that industry is interested and wants to fund like research and development in the space.
Mm-hmm. Yeah. So I guess basically there's sometimes a worry that like blockchain's true meaning will get lost if it's not implemented in the most intentioned way.
Right. Or if it's being used for something where it doesn't really make sense, or, like someone claims it solves a problem that it doesn't, then I think that's, when that's something you'd rather see avoided. But so like, the Intel collaboration I mentioned was really cool because that started because they were interested in blockchain. So kind of like you mentioned, like a company wanted to try and explore the space a bit more. And it was cool because, even though at the end of the day, they weren't like, oh, wow, blockchain is this amazing thing. It's going to solve all of our problems. Like they were able to say, oh, okay, I think we understand the technology, we understand the trade-offs, and we think we can use it for some things, but not for others. And so like getting to a point where there's like intelligent application of the ideas, I think is like the outcome that we all, in academia definitely hope for.
Understood. There appears to be a question in the chat. What are your thoughts on research driven by academic institutions versus by enterprise institutions?
Yeah, good question. And I can speak to this a bit because I spent a summer like at Microsoft Research as a research intern there, which is a bit different than like a software engineering internship. So here, all the interns are PhD students, and usually you're trying to engage in research and either like write a paper or build a prototype system by the end of your time there. And so it was really interesting comparing the enterprise research environment to the academic research environment. And I think they both have a role. I think, probably as you would expect, like at Microsoft, the work tended to be a bit more kind of like goal oriented. Like we have this product or like this system and we want to improve this piece of it, but we don't know how. Let's do research. And that's really good because like there's immediate applications, it's well funded. You get to hopefully have like real impact where your research goes into a system that's part of a product that gets used by a lot of users someday, which is a really good feeling, obviously. And so that's really cool. But I think there's kind of less opportunity for kind of more forward-looking or grander vision than in that kind of environment. Academia is kind of cool because while it's not as directly tied to a specific product or like a specific goal, you can think more out of the box, or you can think about something that maybe won't be exciting today, but will be exciting 5 or 10 years from now. So you kind of get to look further down the time horizon, which is really fun. And I think there's really a place for both of those kinds of research.
That's a fantastic answer, and I think really encompasses what we're always trying to compare between the two. So thank you.
Yep.
I learned something from there. There's another question from Nathan. Recently, Berkeley was ranked on CoinDesk's best universities for blockchain. The main thing bringing down our ranking was the research done. Is Rise Lab considering more research in blockchain?
Yeah, that's a good question. And that doesn't surprise me, although I think there's some things we're doing with blockchain that maybe just aren't as immediately visible to people outside of Berkeley, perhaps. So for example, my work is on blockchain, which is cool. And then Alessandro Chiesa is a professor at Berkeley who's done some really impactful research on crypto primitives, especially around like zero knowledge proofs in blockchain. So I think there are some contributions. I think Rise Lab tends to be a little bit more blockchain application focused. I mean, certainly Wave falls into this category. We took blockchain and we used it as a primitive in our system. And there have been other research efforts in Rise that use blockchain as a component and kind of rely on it, but don't contribute to the blockchain state of the art itself. Actually, another thing I think of now is Dawn Song and Oasis, which is her startup, where they're trying to combine blockchain and secure hardware like SGX to try and kind of improve transaction throughput and scalability. So there's definitely work we're doing. And I think Rise is interested in applications of blockchain, but maybe not as directly in the internals of blockchain itself. So like obviously I would hope they would do more, but I'm not sure if they're like considering anything too much in the immediate future.
Okay.
And then I see another question, Berkeley more broadly, improve its contributions to blockchain. Well, I think BAB is a great start. Like it's really exciting to see like, a bunch of students that are really interested in blockchain and doing like blockchain development and projects and maybe even research. So that's really good. And I think otherwise, it kind of depends. Like this will sound like a cop-out, but honestly, like a lot of the research that happens depends on faculty and grad student interests. And so I guess like the root cause is kind of like we need to increase interest in blockchain among faculty and grad students at Berkeley because they kind of set the research agenda. And so I think there's a lot of awareness for blockchain. And there's certainly some professors, like I mentioned, who are getting into it, but there certainly could be more professors that could do blockchain research.
Okay.
I think one thing is a lot of the systems people at Berkeley. So this would be like Kubi, if you're taking a class from him, like 162, or like Jan Stoika. I think they're both like appreciate blockchain, but haven't tried to do any cool like consensus or distributed systems research on blockchain. It'd be really fun to see something along those lines out of Berkeley.
Okay. From what I'm understanding, do you think like codification into these previously existing monolith classes like 162, and then having maybe more labs encourage grad students to be interested would sort of further along the future of blockchain and how people can contribute to it?
Yeah, so I think 162 is tough because that class already has so much material in it, and it kind of like it can like even barely kind of touch on distributed systems without distracting too much from other things. It'd be cool, I think, if they did spend just maybe a few slides on blockchain just to expose those students to the idea and how it relates back to the other distributed systems that they see in that class.
Mm-hmm.
That could be one way. Otherwise, I know there was a special topics class on blockchain that Dawn Song led a couple years ago. And I think that got some new people interested. So seeing more things like that could be useful as well.
Yeah. What comes to my mind is Blockchain at Berkeley's recent initiative to revamp the developers decal, where it's not even just going to be as much theoretical stuff, and having people create a product by the end of the semester and really dabbling with the computer science skills, the dev skills necessary to understand blockchain in and out. So I think maybe a lot less like passive interaction with the space and a lot more getting your hands dirty and understanding how the technology works. Yeah.
That could be really cool, or almost like a kind of lab course where you would go through and do some projects, like starter projects in blockchain or Ethereum or Bitcoin. That could all be really cool too. Yeah.
Sure. Do you envision, there's a question. I can ask a question afterwards.
Sure.
So Nicholas Weaver released a video refuting blockchain. If you watch the video, what are your thoughts about it? Also, is Professor Weaver's views prevalent among faculty?
Good question. Well, I know Nick pretty well. I've worked with him on a few different things. I haven't watched the video, but I think I read a post where he said that like cryptocurrency should die and fire or something Weaver-esque like that. So I guess when I read his post, like I didn't necessarily disagree with everything he had to say. But I guess my personal style, like I kind of mentioned before, is I tend to kind of be a reserved judgment or just try and pick out like what are the valuable pieces from an idea, even if I don't agree with all aspects of it. And so I guess like that's the approach I would rather see, someone take towards blockchain. But I think his criticisms were on like proof of work and the energy consumption and cryptocurrency as kind of a questionable application. And I guess I would say to either of those that there's smart contracts and other maybe cool things that blockchain could enable. And obviously there's lots of work on trying to move past proof of work to things like proof of stake, or more kind of traditional PBFT based protocols for consensus. So I think the blockchain world is aware of some of those criticisms and is working to address them. In terms of how prevalent his views are among faculty with blockchain, I mean, I think you'll find probably some that agree with him, but lots that don't. I already mentioned lots of professors that think blockchain is cool or have used it in their research. Most of the professors I've talked to are at least interested or kind of aware and open to it. So my personal impression is that more faculty are at least aware and supportive of blockchain, even if they're not engaged with it directly, rather than kind of dismissing it out of hand and saying that it's something not worth research or learning about.
Totally. I think intellectual like conversation is so important. Like at least people are spending time investigating and like trying to formulate an opinion on it rather than dismissing it outright. So
Right. Well, and I guess it is healthy to have people coming from both sides as long as they, can learn from each other and move forward from that. So maybe it's a good thing that not all the faculty at Berkeley think blockchain is this amazing world-changing thing, because then there's going to be some discussion on what are the pros and cons and where's the research and the long-term vision gonna be.
right. There has to be some people who are enthusiastic about it, some people against it, some people who think that blockchain just builds upon previously existing technologies. So
Right, right. And I think, well, I mean, I guess I haven't seen the video, but I think even Nick would say that like there's pieces of blockchain that are interesting or worth learning about from like just a knowledge perspective. So I've like, for example, I've been in like research presentations with him on blockchain where the speaker is talking about cryptocurrency or other things. And like, he's perfectly polite and interested. So I think, he has some strong opinions, but I'm sure he's, still open-minded and trying to learn new stuff too.
how would you recommend for the undergrads watching to acquire enough knowledge to make those strong opinions?
Yeah, well, two things. I would say like go out and like read a lot of stuff, and in particular, like reading, if you want to talk to academics, most academics really think in terms of research papers as like the authoritative source of knowledge in their field. And so it's a skill you have to practice and acquire, but learning how to read academic research papers and digest them is really valuable. It gives you a lot of knowledge, and then you can cite them as evidence when you're trying to argue for your own opinion. And then I would say also just like try to surround yourself with other interested and smart people and talk to them, exchange ideas and notes, and have these discussions where there might be some disagreements, because you're going to learn a lot from those as well. So reading, learning how to read papers, and then talking to other people. Those are the things I usually do, like if I'm getting into a research area and want to learn and form some opinions.
That is very informative. No need to go down medium rabbit holes. Just go straight to JSTOR. Or
Yep, or Google Scholar or the ACM library. Yep.
truly, I think this is gonna be some of my last questions. But what do you what ideally would happen to the blockchain space that could really ramp up its future like higher level of scalability and like government codification and things like that?
Yeah. Well, one thing I'm watching kind of closely is like the whole Ethereum 2.0 effort, because I think they're trying to address a lot of the concerns like around scalability and contract design and robustness that people have raised, we've talked about, and other people have raised as criticisms. And so I think if that succeeds and kind of reaches a certain level of scale, I think people will look at it and kind of get excited or realize that blockchain really could be tractable for some use cases they maybe didn't think about before. So I think we're getting there. I think it's just going to be seeing more working systems and seeing them prove themselves over a long time. That's going to make people more confident in blockchain overall.
Okay. Um, how can about confident? I think that's how do we sort of point people who are skeptical of the technology or have like bad associations with Bitcoin because they inevitably like conflate the two? Like,
Right.
is that always going to be a problem, or can we do something about it as budding academics?
Right. Well, I guess like I would point them to maybe like, the first step would be pointing them to like contracts as maybe, one step past cryptocurrency as a more customizable, extensible blockchain that can hopefully do, tolerate arbitrary use cases. And then I would maybe try and point them towards a few kind of well argued or well understood use cases, like, the whole microgrid example, I think is a good motivator. And show that, although like we're not there yet today, like there are these cool ideas where you can really see blockchain as this really important enabler. So that's like the first thing I would do. And otherwise, I would just tell them, like, if they're technically inclined, I would encourage them like to try and find what pieces of blockchain they still think are interesting or exciting or could be useful. Because as you said, like it's not all just cryptocurrency and Bitcoin.
No, yeah, exactly. And I think people need to have the technical knowledge first before we throw all these social good use cases at them where blockchain saves
Right.
blockchain saves human rights. It's like first people need to be on board with what these words mean, but then they'll really realize like all the academic promise that they can harness.
Yeah, I think that's a really good point, which is like finding something in the middle where it's not this like really kind of pie in the sky application that might work but seems kind of very grand versus something that's more technical and kind of quantifiable as like a good starting point. Yeah.
Yeah. I think this will be like one of the last questions, but for you, Jack, outside of cryptocurrency, do you see any other really interesting use cases of blockchain? Like your true
Right. Yeah. Well, I mean, I guess maybe this will not surprise you, but like I think contracts are like for me like the coolest part of blockchain and the part I'm most interested in. I'm working on it, and I think that's going to be like the real enabling factor in applying blockchain to lots of things. Just this idea, right, that you can enforce this protocol between parties that don't trust each other. And obviously, we're a long way to go from kind of the code as law vision, but trying to get there is, I think, really exciting. And then in terms of like using contracts for specific things, the energy grid idea I think is pretty cool. So that might be one that I would point to as like a really exciting application of contracts to a use case.
Yeah, I think the contracts part is really essential because it can sort of, especially if there's like a punishment component to it, it can sort of disincentivize like um, unwarranted, uncooperative behavior and really stoke a lot of the negative opinions people have about the technology. So I'm definitely going to be keeping a closer eye on contracts and understanding how that space has sort of changed.
Yeah, it's very cool, and especially like if you've kind of like studied distributed systems, it's fun to see like this new kind of idea come into play. Like, a publicly open place for everybody to potentially collaborate where the code is really what everyone's relying on. It's like this cool vision, but as I said, we have work still before we get there.
Totally. Well, thank you. I mean, I think that leaves us with the position of having to figure out what that work is. And if you can, we look forward to figuring out more about your research as it comes about. So I hope we can meet again and keep in touch with how the research manifests. So
Yeah, thanks for having me. It was a lot of fun, and I hope that everybody found something interesting or something thought-provoking.
Yeah. Well, thank you again. And I guess this concludes. Yeah.
All right, great.
Okay. Thank you so much